Dear friends, the edge of the universe is a topic that has fascinated scientists and astronomers for centuries. According to observations made by astronomers, there is no edge to the universe. The universe is constantly expanding, meaning that space spreads out infinitely in every direction. Galaxies, nebulas, and stars fill out all of the space throughout this infinite universe. In the past, Galileo first time pointed his first telescope to the heavens in 1610. He discovered congeries of innumerable stars, hidden in the band of light called the Milky Way. Our cosmos grew exponentially that day. Roughly 3 centuries later, the cosmic bounds exploded once again when astronomers built telescopes big enough to show the Milky Way is just one of many island universes. Soon they learned the universe was expanding, too, with galaxies retreating from each other at ever-accelerating speeds. Since then, ever larger telescopes have shown the observable universe spans an incomprehensible 92 billion light-years across and contains perhaps 2 trillion galaxies. And yet, astronomers are still left wondering how much more universe is out there, beyond what they observe. The universe has always been slightly larger than what we can see. Building bigger telescopes won't help extend the cosmos anymore. Telescopes only observe the observable. You can't see back in time further than the age of the universe, so we are totally limited. We've already seen as far as you could possibly imagine. At the edge, we see the leftover glow from the Big Bang, the so-called cosmic microwave background radiation, CMB. But this isn't some magical edge of the universe. Our cosmos keeps going. We just may never know how far. In recent decades, cosmologists have tried to solve this mystery by first determining the universe's shape, like the ancient Greek mathematician Eratosthenes calculating Earth's size using simple trigonometry. In theory, our universe can have one of 3 possible shapes, each one dependent on the curvature of space itself: saddle-shaped, negative curvature; spherical, positive curvature; or flat, no curvature. Few have championed a saddle-shaped universe, but a spherical cosmos makes sense to us Earthlings. Earth is round, as are the sun and planets. A spherical universe would let you sail into the cosmos in any direction and end up back where you started, like Ferdinand Magellan's crew circumnavigating the globe. Einstein called this model a finite yet unbounded universe. But starting in the late 1980s, a series of orbiting observatories built to study the CMB made increasingly precise measurements showing that space has no curvature at all. It's flat to the limits of what astronomers can measure. If it is a sphere, it's a sphere so huge that even our entire observable universe doesn't register any curvature. The universe is flat like a sheet of paper. According to this, you could continue infinitely far in any direction and the universe would be just the same, more or less. You'd never come to an edge of this flat universe. You'd only find more and more galaxies. That's all well and good with most astronomers. A flat universe agrees with both observation and theory, so the idea now sits at the heart of modern cosmology. The problem is that, unlike a spherical universe, a flat one can be infinite or not. And there's no real way to tell the difference. What could you look for to see whether there's an infinite universe? Trimble says, nobody quite knows. In conclusion, the edge of the universe remains a mystery. Despite our best efforts to understand it, we may never know where it is or if it even exists. What we do know is that space spreads out infinitely in all directions and is filled with galaxies, nebulas, and stars. The possibilities are endless.